Hey everyone, welcome back to the channel. Today we're talking about something straight out of a sci-fi movie. But it's very, very real. The sun's fury. Specifically, we're diving into coronal mass ejections, or CMEs, and answering the big question, when will the next big one hit Earth? So what exactly is a CME? Picture the sun not as a calm, steady ball of light, but as a super hot, bubbling cauldron of plasma. This plasma is constantly swirling, driven by incredibly powerful magnetic fields. Sometimes these magnetic field lines get twisted and tangled up, like a bunch of rubber bands wound too tight. When they suddenly snap and realign, they can launch a colossal bubble of plasma and magnetic field out into space at millions of miles per hour. That explosive release is a coronal mass ejection. Think of it like this. You shake up a can of soda. The pressure builds and builds. When you pop the top, it explodes everywhere. A CME is like that, but on a cosmic scale, releasing the energy of billions of nuclear bombs all at once. It's a truly mind-boggling amount of power. Now, not every CME is aimed at us. The sun is a giant sphere, and it can fire these things off in any direction. Most of them just fly off harmlessly into the vastness of space. But every now and then, one comes barreling right towards Earth. So the question isn't if one will hit us, but when and how big it will be. When a CME does hit Earth, it doesn't just pass by. It collides with our planet's own magnetic field, the magnetosphere. This is our planet's invisible force field, protecting us from the constant stream of charged particles from the sun, known as the solar wind. A CME is like a tsunami of solar wind, and when it slams into our magnetosphere, it squashes and distorts it. This collision triggers what we call a geomagnetic storm, and this is where things get interesting for us down on the surface. The most beautiful effect of a geomagnetic storm is the aurora, the northern and southern lights. The energetic particles from the CME get funneled down the magnetic field lines near the poles. When they hit atoms in our upper atmosphere, they excite them, causing them to glow in those beautiful dancing ribbons of green, pink, and purple light. During a strong storm, these auroras can be seen much farther south than usual, sometimes even in places like Florida or Texas. But it's not all pretty lights. Geomagnetic storms can cause some serious problems. The same energy that creates the aurora can induce electrical currents in long conductors on the ground. What are long conductors? Think of our power grids. Thousands of miles of interconnected wires. These induced currents can overload transformers, causing them to overheat and fail, leading to widespread, long-lasting blackouts. This isn't just a theory. It's happened before. In 1989, a CME caused a geomagnetic storm that knocked out the entire power grid of Quebec, Canada, leaving 6 million people in the dark for 9 hours. And that was considered a moderately strong storm. Our modern world is even more vulnerable. We rely on electricity for everything: communication, banking, transportation, water pumps, refrigeration for food and medicine. A major blackout lasting weeks or even months would be catastrophic. And it's not just the power grid. Satellites are right in the line of fire. The high-energy particles can damage their sensitive electronics. A phenomenon known as satellite drag can cause their orbits to decay, and it can disrupt the very signals we rely on for GPS, television, and global communications. Imagine your GPS not working, your phone having no signal, and your internet being down, all at the same time. That's what a powerful CME could do. It could essentially knock us back to a pre-digital age in an instant. So this brings us back to the main question. When is the next big one coming? The honest answer is, we don't know for sure. Predicting space weather is a lot like predicting Earth weather, but even harder. We're trying to forecast the behavior of a star that's 93 million miles away. However, we do have some clues. The sun goes through an 11-year cycle of activity. It swings from a period of low activity, called a solar minimum, with very few sunspots and flares, to a period of high activity, called a solar maximum, where the sun is covered in sunspots and CMEs are much more frequent. Right now, we are ramping up towards the next solar maximum, which scientists predict will peak around mid-2025. As we approach this peak, the frequency and intensity of solar flares and CMEs will increase. This means the probability of an Earth-directed CME happening goes up significantly in the next couple of years. We're entering the high-risk season, so to speak. The most famous and powerful solar storm on record is the Carrington Event of 1859. During that event, the auroras were so bright that people in the Rocky Mountains woke up in the middle of the night thinking it was dawn. Telegraph systems, the high-tech of the day, shot sparks, shocked their operators, and even caught fire. Some operators found they could disconnect their batteries and still send messages, powered purely by the electrical currents induced by the storm. If an event of that magnitude happened today, the consequences would be on a completely different level. A report from Lloyd's of London estimated that a Carrington-level event could cause trillions of dollars in damage and take anywhere from 4 to 10 years to fully recover from. It's a low probability but extremely high-impact event. Experts believe a storm of that size occurs roughly once every 150 to 200 years. Well, it's been over 160 years since the last one, so statistically, we're in the window. So are we just sitting ducks? Not entirely. Scientists and space agencies like NASA and NOAA are constantly monitoring the sun. Satellites like the Solar and Heliospheric Observatory, SOHO, and the Solar Dynamics Observatory, SDO, give us a 24/7 watch on the sun auroras activity. When they spot a CME being launched towards Earth, we can get a warning. The problem is the warning isn't very long. A fast-moving CME can cross the 93 million-mile gap between the sun and Earth in as little as 15 to 18 hours. A slower one might take a few days. That's not a lot of time, but it's enough to take some precautions. Power grid operators can take steps to protect their systems, like redirecting power loads and bringing extra transformers online. Satellite operators can put their spacecraft into a safe mode to protect their electronics. So, the next big one is coming. It could be a moderate storm that just gives us some amazing aurora displays and minor satellite disruptions, or it could be the next Carrington event that fundamentally changes our modern way of life. We don't know when, but we know it's a matter of when, not if. The key is to be aware and prepared. Scientists are working hard to improve our forecasting abilities, and engineers are developing ways to make our infrastructure more resilient. For us, it's not about panicking, but about understanding the universe we live in. The same star that gives us life also has a powerful wild side. It's a humbling reminder of the immense forces at play in our cosmos. Thanks so much for watching. I hope this gave you a better understanding of coronal mass ejections and the very real impact they can have on our world. If you found this interesting, be sure to hit that like button and subscribe to the channel for more deep dives into the wonders and dangers of our universe. Drop a comment below with any questions you have, and I'll see you in the next video.